So for those who don't know me, my name is Dernis Mediavilla. I am the head of innovation of the European Marine Energy Center. My background officially is in physical oceanography. I did officially, yeah, physical oceanographer on an undergrad in the University of Buenos Aires. I am from Argentina, actually. And I did my PhD in the University of Concepcion on wave energy, spectral energy transfer on waves, soil tracking, and those magics. So although officially I'm an oceanographer, I should say that it's been a while that I haven't used my skills technically, except very, very briefly here and there. After finishing my PhD, or I should say, while finishing my PhD, for those who know, I ran out of the scholarship and I started a job. And I started a job happened to be at a Marine Energy Research and Innovation Center in Chile as a technical coordinator. So way out of my academic comfort zone back then, but I totally loved it. And I started to understand the different disciplines that interplay on marine energy. I started to learn about the technologies and all the different types of knowledge that we need to have in place to actually make the technologies a reality. So, everything has to do somehow with marine energy, social science, biologies. It's not only the engineering of the technologies, not to downplay that, because of course it is critical, but these technologies don't live in a void, which I keep learning in my stay at EMEC. I joined EMEC 5.5 years ago as the Marine Energy Development Coordinator. That is the person that is in charge of helping developers come to work with us or help them wherever they are deploying as well. So kind of opportunity tracking, proposal writing, and, a lot of talking, understanding, and very, very big amount of learning. And from then I went to be the commercial manager, and now I am the head of innovation. I will tell you a little bit more about that by the end of the presentation. I will do my best not to talk at 1,000,000 times per hour, that I might fail. So if you want to stop, want a clarification, want to ask a question, please do raise your hands. We will have some time at the end for a Q&A. In case you want to just, dump your thoughts on the chat, then we will go back to them by the end of the presentation. Or again, I'm very happy to do this in a way of a conversation. And here are questions or thoughts while we go. So this is where technology starts. Yay! It is moving. It's moving in the right direction. So the European Marine Energy Center is positioned as an innovation catalyst. We are a non-for-profit research and innovation institution, and that is originally focused on wave and tidal energy converters. But with time, we have expanded a little bit more beyond that, including then in the integration of that technology to alternative offtakes offshore, and also some history on hydrogen and such that I will not touch in detail right now, but in case anyone is interested, you will have my contact by the end of the slides. And basically what we do, our core is still testing and demonstration of technologies. We are based in Orkney Islands. For those who don't know where Orkney Islands is, let me see if I can do the magic of the pointer thingy. It might fail. There you go. So this is Orkney Islands. Basically, you just go to Scotland, drive north, run out of land, hop on a ferry, and you will be with us in the Orcadian archipelago. If you keep going, this is Shetland. Just go back, it's just too far. We then operate 4 test sites. 2 of them are grid connected, and 2 of them are scale sites that are not grid connected, that are the ones that are closer to shore. We have been working since 2003, and our facilities have received £39 million of investment from different entities, in general, European and local government. So the pictures that you see there on the top is what we call the Fall of Warness. That is our tidal site. This one is grid connected. We have 7 cables in there operational. And you can see, well, you probably can't, but here is where our substation sits. And down in the picture below, that is Viglia Crew. As the picture speaks by itself, it's quite wavy. So that is our wave site, and on it we have 6 berths connected to the grid as well. Needless to say that these 2 sites are, how can I say this, are the real deal. I mean, we are talking about big currents, big waves. They are basically there to get machines tested. If they survive here, they probably have a really good chance of surviving in many other places. That's the reason why EMEC was based in Orkney, is because of the closeness of both a high wave resource and a high tidal resource. For those of you who probably already know, that doesn't happen everywhere in the world. In particular, talking about tidal energy, there are very specific sites around the world where that, where you can find 4.5 plus meters per second currents. So this is one of them. But the thing is that the technologies themselves, if you think about technology developer, for those of you who are not one, and your design, you start perfecting it, you start building a prototype, you manage to get it on a tank, which is a fantastic experience, and we cannot recommend people going through tanks enough. You will learn tons out of it, but there is a point that you are like, okay, I really need to test this on the environment I need to potentially operate it. And we realized that going straight forward to the Fall of Warness or Viglia Crew, our wave and tidal sites, could be a little bit too wild. So that is where the idea of the scale sites came from. That are these 2 orange dots that you see here, that, as I said, they are closer to main harbors and shore, and they are much easier to pop on and off. This is the one in the south is Scapa Flow, that's a wave site, and the one in the north is Shappinsay Sound, that is the current site. Oh, I had more pictures. There you go. So if I show you a picture of the scale sites, it's going to be more lovely Orcadian landscapes. So better to show you a little bit of a diagram of what they look like. So in the scale sites, as I was saying, we don't have subsea cables, but we do have some mooring points. We do deploy our own it's like ancillary equipment to support developers who would like to connect to something in the shape of a test support buoy and a microgrid that is power bank, and giving some loads out of it. All our test sites are instrumented, meaning Viglia Crew has 3 wave rider buoys operating. One of them, we try to maintain one of them in a long time series that has been measuring for more than 10 years. And then our tidal sites, especially the Fall of Warness, has many ADCP drops. That is the tidal, current meters, let's say, Doppler current meters. So we have done 66 ADCP campaigns so far, of which not all data has been good, of which not all data is ours. But they are very well understood sites, I think, both of them. Okay, this is it. There you go. Just not to go back to this too much, but just for you to understand where we are, where EMEC operates. We operate in what is called the Valley of Death. I know, a little bit gloomy for a Tuesday near midday. But it is called the Valley of Death because it is, as I was saying before, this moment where developers are jumping, and it's a big jump from a tank to, you know, the real world. The real world, the real ocean requires boats, requires divers, requires permitting. You know, if you want to plug, requires cables, substations. Like, it's a big maze. And that is where I think EMEC stands. And I might extrapolate this to all of the other test sites that are around the world. We are there to actually help developers to not have to put the big bucks. It's still expensive, but it's not as expensive as you actually doing it on your own. So what we do is we offer pre-assessed sites. That mean that we do have an environmental baseline on them, and developers have to apply for their own marine license. That, as long as it is within the envelope, you can have a more straightforward pathway to permitting. Permitting that, again, if they are going to do it on their own, will take a lot of time, not to mention the risk. Then, well, the cables are already there. So we just do like a rental model, let's say. And all that, although again, I'm not minimizing the cost of setting the infrastructure, the cost of operating the infrastructure. We are a non-for-profit entity, so we are a cost recovery entity. So basically, it is your best bet unless you want to do this on your own as a developer. That is where the Valley of Death is, and that is where many technologies, even with the support of test sites, not only EMECs, have unfortunately, you know, didn't quite make it. It is the last step, that last step where you have your machine, you can actually demonstrate that is out there doing what it's supposed to be doing, generating power, and proving the business model that you have behind them. This is, you will hear me talk about money a lot. It's not because I used to be the commercial manager, it's also because it is the reality we live in. And we also understand as EMEC the pressure, the big pressure that developers have on their backs to actually make it work on their own. There are no many project developers in the sector, not to say none. So the people that create the technology is also in charge of actually making that business model and showcasing that technology, that it is actually working, that it's actually giving the numbers. And we do live in a numbers world, although we all cherish for the bigger goal of actually finding other ways of extracting energy that is not burning dinosaurs. So we can keep talking about that, as you can imagine. So far, we have seen 35 devices on site, and with 22 developers from 11 countries. This is a little bit of a nice timeline of what has happened at EMEC and what is still happening. You can see on the, you see two timelines. The timeline on the top is the tidal energy devices. The timeline on the bottom is the wave energy devices. You will see there are a couple of firsts. You will see Open Hydro platform. That was the first turbine of its type to be connected to the grid. I mean, I am discarding tidal range and those technologies that exist from way before. And Pelamis was the first wave energy device as well, connected to the grid, having here at EMEC. And the advantage of having access also to a test site is, as you can see, Open Hydro, for example, they have this really huge timeline. We finally decommissioned the structure in 2024, beyond the unfortunate disappearance of the company itself. But what they have been doing with the structure is actually using it as a point of testing and iteration of their own innovations within the technology, even if it is the PTO and things like that. It has stayed there for, let me see that, more than 10 years, doing its thing. So the iterative testing is one of the main things that our developers have been doing in our site. And as you can see, this is the case that probably is known for many of you of orbital marine power that started back then a long time ago as called renewables. And you can see there on the screen the different shapes and sizes of their tech until, we saw the latest version and to becoming the arrays of their device. Again, if you want me to stop at any point, just raise your hand. I see that people are writing stuff in the chat. I am not opening that right now because I am with a single screen and this would be just too complicated for everyone, or at least especially for me. Suddenly we jump to data centers. Yes, the thing is, we have 4 test sites, okay, that are there to support innovation, that are there to originally as wave and tidal focus, but being a company that is risk-friendly and high health and safety orientated, we are very happy to actually host other type of innovation going on underwater. And this is one of the examples that I can show you that has happened on the center. So Microsoft came and said, I want to see if actually putting a center underwater can be, more beneficial in terms of helping me with heating, and apparently, the results were nice and positive. Cool images. I was about to cut the video, but then I understand that it is a really nice video. Okay, I'm doing it. On that note, as I said, Microsoft is one of the things that we have had on the site that are not wave and tidal energy converters. The way I started my conversation today earlier is the moment that I personally realized that marine energy is much more than the technologies. Marine energy also needs of materials, of coatings, of understanding the impact with the environment that these machines sit in, on understanding how the environment impacts them as well, because it's not only how they move with the flow, it's also how that flow, the changes in the flow, how potentially, massive algae in Chile, that were a total thing, can actually entangle in your machine and so on and so forth. We are also talking about all the ancillary technologies. A very wise man, EMEC ex-director Neil, maybe you have met him, you had the pleasure, and he usually says that, when you go on a plane and, the plane itself is, needless to say, a fantastic piece of engineering. You sit there and you want to go to the toilet, and there is this tiny light that tells you if the toilet is on or off. And it's not the airplane, but oh my gosh, the tiny light is actually helping so many people not walk around the hallways and asking people to move just because. And it's part now of what the technology is. Those type of ancillary, stuff that work around the system are really important as well, are not core, are not the thing that will define if you're actually extracting as much, electricity as you can, if you're using the less amount of fuel to fly your plane. But at the end of the day, it's really important because many of them actually can help you to reduce your costs. Marine energy is not a sector that can, access to finance in the way that the oil and gas sector is. Think that we are talking historically, the big engineering projects that have survived in the water, 20, 30, 40, 50 years, are oil and gas. Majority of them, almost all of them. You are talking about vessels. Yeah, vessels move. Vessels can go to shore. You go, to your shipyard. You clean them on shore. It's very hard to do that with a marine energy converter because every time that you unplug them, you're losing money, and also it is very expensive to, take them off, bring them to shore and clean them and do any maintenance you would need to do. You want to design a technology that is capable of surviving and thriving on the marine energy environment with the less amount of maintenance possible. And this is where R&D and innovation meets the developers. Because developers, and fair enough, they are very focused on, the improvement of their own devices. But us, me, physical oceanographer, many of you out there, the next on the screen, you might not be the one designing and building the device, but you might have ideas that can actually help to bridge that gap and to help these machines to be commercial in the future. Could be doing clever sensor stuff, doing clever material stuff, doing clever connectors, clever cables. Umbilicals are always a fun thing to have and operate and see when they might break. Forecasting, like there is so many things that work around the technology. Not to mention, cool, we have a machine that is generating electricity. What are we plugging it to? Yes, common answer is the grid, true. But are there other markets? Are there other needs that we could be fulfilling with a source of energy near shore or offshore? Yes, there is people that already studied this. If you are on the sector, you might be aware. The US have done massive reports on this, the power in the blue economy and so on. Today, we talk a lot about data centers actually in terms of consuming power. So there are many ideas out there, and the ones that can actually support that integration and that alternative offtake are not necessarily the ones building the machine, are the ones that actually are looking at the holistic picture and saying, actually, this would make a lot of sense to plug, to connect to support this community, to support, this new e-fuel that we are generating. Many of these technologies, especially tidal ones, are technologies that are going to be deployed and connected at the end of a grid in isolated areas just because of where the resources. So having these, socioeconomic view of what could be that approach to actually support a community and what kind of technology we might need to do that is also very important. So in this slide, it's just a quick glance. We have learned along the way as EMEC, amongst many partners we have worked with, the importance of actually looking at these type of projects as well. So a few examples of environmental work on the screen. We do a lot of acoustic monitoring. We're doing echo sounders. We're doing sonars. We are working also under Horizon Europe projects with Orbital and with Ocean Energy on their deployments as well, with more of an integrated approach to environmental monitoring. We're learning to do that actually, not that we actually know how to. That's part of the game. And then we have done resource assessment. We have supported actually Edinburgh University on a deployment of a really, really cool piece of instrumentation. And we have done materials, as I was saying, coatings, and the supported universities as well, doing studies on corrosion of the commissioned infrastructures. And then this is the world of all the components and subsystems that I was hinting at before. So, quick connectors and, robotics, yes, definitely. Mooring lines, that is the EV connector that we tested not that long ago. And when I say we, is that we are the glue that connects the developer, the local supply chain, and we give them a space to actually do it, and we take care of the health and safety of the overall operation as well. So what is coming to EMEC? I promise to leave time for questions. Okay, I'm okay. So what is going on now? What is coming? We have a Horizon Europe project starting recently that is called Forest. We coordinate it, so you can blame us for the name. How we managed to put a name based on trees to an ocean energy project, I will keep that secret, okay? But it's called Future Ocean Renewable Energy System Technologies, and it is focused on, I will say, one of the critical technologies that we see developers trying to figure out. That is the connectors, cables, and the whole sensor and operational information, a little bit of AI, because, you know, of course, we want AI in a project, to monitor the cables actually and optimize, you know, performance. Cables have temperature differences and they do all the things that probably you electrical engineers know much better than me. So the that project just kickstarted not long ago. So stay tuned to see what is going on and what results we will be having. But in terms of machines in the water, we have on the left side of the screen, you can see wave energy. So what you see is another Horizon Europe project that is going to see Ocean Energy coming to Villa Crew to test their new device. The recently announced Core Power Ocean, also Horizon Europe project, to see an array of Core Power devices coming to Villa Crew as well. And also Symphony Wave Power was awarded with the Rise Energy support grant to cover the cost of their testing, part of the cost of their testing at EMEC. So they are coming to Scapa Flow, that is a scale test site. And on the right hand of the screen, I hope the screen is not flipped. Anyway, the right hand of the screen is showing you the tidal developers. All of them, as if you have been following allocation rounds and CFD contracts, these names ring the bell, and you kind of already know that they are coming. Orbital Marine is coming with an array of devices, as well as Nova, both of them with the Horizon Europe project behind, and Magallanes Renovables, who actually did the first fully commercial funding of tidal energy technology, coming to site as well with their new generation, with 2 more machines under the allocation round in the coming years. So things are going to get busy. Yes, that's the way we like it. We like machines in the water. We like seeing things getting busy, but we also understand the challenge. We have been learning a lot on single device deployments. We still think that there is a lot to still learn from single device deployments. The things that we like, the resource, the modeling, but it is true that having multiple machines, especially of different types of technologies, maybe the same type, different developers of technologies, is also a great opportunity to do some integrated research that can look at the cost effectiveness of an array level setups. So from here, you might have seen in the news, we were awarded £15 million from UKRI towards the Fall of Orkney's expansion, because I just said, busy. So we need more grid. We already submitted an expansion of our consenting. So all that is shaping, and those 50 millions will go directly to the onshore infrastructure that we need to have in place to accommodate developers coming to site properly. So this is a video that wasn't supposed to be exactly here, but it's an interpretation that one of our communications team made that I really like. That project is called Blue Horizon. This has been announced a few days ago, so it's still very new, and this is kickstarting then soon. So also stay tuned. Okay, let me take a breath. So what else do we do? Because, apparently that might not be enough for a self-financed company. One of the gaps that we have seen in terms of technology testing is this idea, you take the same product and you take it to a new market. We said, hey, we have been supporting testing and demonstration of innovative devices offshore for 20-something years. So why not go big? And we are working towards the setup of our floating and deep wind test site that is a little bit farther west from Villa Crew. And again, it's still a little bit early stages. We have a business model in place. We have support from the Crown Estate Accelerator to do the pre-feed of this. But we are acting as fast as we can, as fast as permitting and grid and baseline studies allows us, on funding, and expecting to have the site ideally offline end of 29, beginning of 2030. This will accommodate then, as I said, deep water and floating wind technologies. Again, same approach. We will be the site operator, and technology developers will come and rent their berths, their positions, and deploy and test their technologies. Especially, well, probably don't need to go into too much of this. You might have heard that the wind sector is not going through the best time right now, and it's actually this type of activities that de-risk technologies offshore, where you can actually go and learn how floating things and connectors with them might not play ball the way you thought about on paper or on a tank. Those are the type of things that will give actually more solid engineering, and also will be confidence to the investors you are speaking with, showing evidence that your machine can actually take the weather that the North Sea has to offer. Then, as I said, we have test sites and we're not afraid to use them. We are also part of the International Blue Economy Robotarium, where we would love to get together and get some robots in the water, because who doesn't? It is actually a cluster of entities supported by the National Robotarium, where we want to basically put robots to the test and get them work towards the blue economy. That is maintenance, that is observation, that is any sort of activity that can be automated, especially if we're talking about de-risking human life, reducing the cost of activities offshore. Maybe there are many things that we don't really have to send a human to do. And those are the things that the Blue Economy Robotarium will be focused on. It is, again, just starting. There is a website out there, and we are a part of it. So also stay tuned. Last but not least, integration. So as I said before, marine energy doesn't live in a void. And coming from the fact that Orkney in particular is a place that has a great problem, and is that we have too much renewable energy to export to the rest of the UK, because for now, that is being upgraded, but for now, the size of the cable that connects Orkney Islands to the mainland is too small. So from there, we said, well, we have been supporting demonstrations offshore. Let's see what else we can do with that electricity onshore. You might have heard that we generated hydrogen from tidal energy for the first time in the world in our site. We also operate a vanadium battery on site, and that we try to prove that there are other means, there are other ends to the means, there you go, for marine energy that are not necessarily only connecting to the grid. We are working then towards expanding our onshore site to accommodate other types of sustainable offtake technologies in a broad and technologically neutral approach, the same approach that we are taking with offshore devices. You name it. It's not only hydrogen, it's e-fuels in general, could be sustainable data center ideas. You name it, and we are there. Because we like it. We have also been working with the airport to do a demonstration of the CHP unit that has been actually successful, where we provided power and heat to the airport in Orkney, again fed by green hydrogen. And why not? Because we have been in the sector for so long, we're kind of the grannies and grandpas of the test sites right now, we're very happy to coordinate and push forward International Waters. That is the international network of test and demonstration sites for offshore technologies. We have 18 members all across the world. So if you yourself or anyone you know actually is designing, building, putting together, or even operating a test site that they might not know about international waters, do let us know. It is free to participate, and we meet once a year to exchange knowledge and lessons learned, and also to vent, I have to confess. Then a little bit on this integration angle, I'm not going to stay here for long, is the Island Center for Net Zero. That is part of the island deal. That is part of the islands deal that connects main islands in Scotland. I'm not from Scotland, so you can read me. The 3 main islands of Scotland together to help to decarbonize way beyond only energy. We're talking about farms, we're talking about tourism, you name it, and this is where ICNZ sits. So, I told you I was going to talk about numbers. As I said, we don't live in a void. Every action that we do has an impact on the other side. A very, very wise professor, when I was working in Chile, said that the amount of money that in Chile you get for a research project, one of those like open grants, EPSSC or NERC, is the amount of money that would take the country to build a rural medical, point. So if you are getting that money, it's our duty as researchers, as innovators, to actually make it work for society and for ourselves. Every knowledge has a place, but don't lose sight of the fact that I think strongly, as you can hear, that we do have a responsibility towards the communities we live in and the world we are embedded in. So of all this money and R&D projects and all that churn that EMEC has had through the years, we haven't eaten that. It has gone back. It has gone back to the UK, to Scotland, and to Orkney in the shape of GVA, in the shape of FTEs. There is a whole study that we commissioned independently. These are not our numbers, these bigger economics numbers, and to actually show the value that EMEC's 20 plus years have had, and some snapshots of the amount of R&D projects that we have seen through the years. So this is also known as the politician slide for me, because hey, looks like it. And then, so how to work together? And just on time for the Q&A. How to work together? We have a team that is there to support collaborations. We do, as you saw on the slide before, and as you have heard already during the last 45 minutes, we do a lot of R&D grant proposals. So we do that. We are also a research entity that can participate on Research Council applications, as you have seen probably, thanks to the UKRI funding award. And also we do consultancy work, because not everything has the pace of a grant. And we have also worked and keep working internationally to support all the test sites and to support developers also not necessarily coming to EMEC, but willing to work with us out there. What is new on this landscape? The main thing is that we have created an innovation team as of the end of last year. I know, yes, we've been working for more than 20 years on innovation. We didn't actually have an innovation team, but now we do. Not that was missing. What we did was actually merge 2 teams that are now learning to know each other and starting to work together. That is a team that I personally lead as head of innovation. So a little bit early stage, but I do have some plans around it. So for you out there willing to, participate potentially on some R&D key areas work, keep your eyes on socials. I am working on EMEC's innovation roadmap, which will include also strategic R&D topics that I think personally we as EMEC could be very well positioned to focus on. Is all about how we can support better the sector and how we can use this very special position of being embedded offshore and surrounded by different technologies gives us. So it's that. And I am also building a database. I am restructuring our internal database, but I am also building a database that is going to be externally faced. We do have, data sets that can be publicly accessed. We have supported researchers in the past, providing data for their projects. And it's just to streamline this a little bit. And so you can all go and look what we have on hand. So questions, if you have any preference of, platforms that you think could do better for this, do shout. This should be, yes, I mean, it should be comfortable for us, but should be also comfortable for you guys, the end users. So don't worry, you don't have to remember all this. I put it on the slide, and these slides are public and will be shared at the end of this chat. So a little bit of what I was just saying over there, and because I said reach out too many times, that is my email. And be patient with me because, again, new team, lots of work going on. So I apologize in advance if I don't reply to you, but it will not be lost. It will be only delayed. Well, that's all. Thank you, everyone.
Thanks, Dennis. Just there's a couple of questions that come in the chat.
Yes.
We need to answer. I think they'll be really good.
Let me stop sharing my screen so it's easier.
Daniel, about the questions on the value of death later, please, and Q&A. I think, Danny,
yes, thank you, Denise. Yeah, and thank you very much. Yeah. So I actually have a million questions, comments, and ideas around this, and I'm particularly interested in wave energy and the birth of that. And I like tidal, but I realise it's geographical limitations on sites. But I just want to know, because I do have a million questions. I will reach out to you by email if that's all right, and I'll be patient for the response. But so I had a quick sort of comment on the Valley of Death thing. I know that sort of niche ideas can sort of bridge that valley a little bit, and I noticed that wasn't on there, but I just wondered if the sort of your importance in the industry and your connection to private investors mixed with sort of government backing, whether you could team up with like coastal protection and have a sort of multiple function floating offshore devices. And in terms of the cables, I wondered on the feasibility of sort of not having hard connections everywhere, sort of a semi off. I know the grid needs to change, massively, or with the sort of offshore technology, and it's a massive sort of upheaval, for want of a better word, and whether that sort of I know that there are in the shipping industry there are ammonia engines being created by MAN and companies like MAN at the moment, which are trying to get that sort of environmentally friendly bit. I mean, if you sort of all teamed up together, I just wondered what you sort of know about. I mean, if you could have like a floating sort of refilling station, then that's away from the shore for these new sort of ships. And potentially not having. I mean, I know they got problems. They have to make their vessels larger because of the lack of energy density of the ammonia, etc. And that sort of not. They wouldn't have to be if we had sort of further offshore refilling stations. They wouldn't have. They could fill up more frequently.
Yes, as you said, many ideas, Daniel. So the main angle, I guess, right now for testing technologies offshore, either integration technologies or generation technologies, one of the main question marks is not only, of course, the survivability of that ideas, but also the health and safety, which is kind of, paramount to make sure that we help the sector to progress the way it should be. So ammonia ideas have been around the table for a while. Also devices that are more of a, nature application or are more nature friendly and all that. Because they are still not at a high TRL, in general, conditions seem to be very much similar to the other type of technologies, meaning that regulators have an eye on this is to learn, this is new, so their requirements independently of the end use of the technologies are, more or less the same. In our personal case, it's not that complicated because as long as technologies fit within the environmental envelope that we have agreed with the regulators, it's more or less straightforward. Then you did mention at the beginning a good point that I have been discussing with all the test sites as well, and there's this thing of test sites being, as proxy as you can get to a project developer. Although we are technologically neutral, we are very close to what developing a site looks like, well, because we operate them. And so although we don't do the financing bit, we are the ones that can actually say, these are the costings, this is the upside downs, these are the lessons learned. And we can certainly help to, de-risk it in the eyes of the people having money on their pockets. Well, that was a very general point. But yes, please do feel free to reach out. You can find me on my email or on LinkedIn as well. My name is peculiar enough. It won't get mixed.
But thank you. Yeah, sorry about the long sort of question.
It's okay.
It's sort of all linked in. So yeah, thanks a lot.
Yeah, I think Danny as well. There's a following on from Sandy Gunn that literally worked with our RTOs and can also discuss the value of death process. I think that's what she put in there. So Sandy, if you can reach out to Daniel as well, that'd be good.
Yes, please.
There's one from I didn't get. Were you from? Obviously, you sound like from Wales. Your accent, but I don't want to sort of say that. So, whereabouts are where are you based?
Yeah, so I'm based Newbury, Reading. I did a sort of brief. I had a brief time in Plymouth, in University of Plymouth, with doing the Masters of Offshore Renewable Energy Engineering, which it's a big passion of mine. And yeah, I'm sort of if I could move to Scotland, to Orkney, I would. But yeah, this is sort of where I am to stay. Yeah, but please get in touch, and I mean, I really want to talk and sort of bounce ideas and yeah, and things like that. Cheers.
Well, like all our webinars, they're all recorded. So if Sandy, you want to get in touch with Daniel, that would be good. That'd be good. I think there was a question from Jordan about slightly terms of EMEC, which is great. How do you plan to monitor the interactions in innovative technology with the environment from the seafloor and the water column, both temporal and spatially?
Yes. So the two sides to that question, Jordan. One is what we would like to do, and the other one is what we can do. So those projects are backed up by Horizon Europe funds, and each of them have, orbitals, and NOVAs have an environmental work package within them. So to, as a particular example, to double click on the orbital case, we have been working with them from Forward 2030, the Eurotides, now into understanding how we can do an integrated monitoring system for them. We have acoustics, we have echo sounder, we have sonars, ADCPs, of course, with the fantastic support from Orbital's team as well, integrating all of this between the device and letting us, measure around them and all that. So that is to have a better idea of, in particular, fish and moving mammals that are a key thing right now in the north of Scotland, in case you might be aware as well. There is a nice report done that is publicly available, supported by the Crown Estate Scotland, that is called TISP, on seal population, that also comes from, discussing with the sector. Then we have our sites. I am reshuffling our numerical models, but I am very, very keen to keep supporting researchers and also start doing our own understanding of how those machines interact with each other, and how also, the energy extraction from the site might or not alter the ecosystems around them in the shape of, sediment transport and coastal dynamics. That also goes for the wave site as well. Core Power has also, under the Horizon Europe, an environmental work package as well that we lead, that has, again, echo sounder acoustics that drill the usual suspects for it. Then what we would like to do is probably much more, but the thing is always, the funding behind it is not cheap, as many of you know, to go out there and to measure. And it's also, challenging when we're talking about integrating systems. And I have loved seeing passing by and participating on proposals that actually have an integrated approach between engineering and nature sciences. I don't see them often enough. And maybe this is a push for all of you who might have been hesitant about it. Please, we do need more holistic approaches for and to understand the impact of the devices in the water. It's not about only the seal. It's also about, the rotation of the blades. It's about the turbulence. It's about, bubbles trapped on your on your sonar images. It's about everything. So yeah, I guess that is a tiny moment of venting. Yes, and as a sector, just to keep learning, and as our small contribution on the shape of data, when that's ready, will be also advertised on social media and LinkedIn and all that, for all of you guys to go and do what you do best, that is deep thinking and coming with cool ideas.
Yeah, absolutely. A slight plug. There are acoustic sort of sensor tests and stuff that we've funded and stuff through Supergen. So have a look at that. We'll obviously work closely with EMEC as well about different things, but absolutely, keep us informed about this sort of stuff. The more we know, the better we can do something about it. Just sort of, I guess, the last question, because we're up to our time really. Just the last one, if we can give like another 5 minutes, if that's all right with you. Maria sort of saying Ireland is pitching the 20 years of impact slide, or EMEC involved in test sites in Ireland, or indeed tests with Irish partners.
Yes, we do have Irish partners that are part of international waters, and we have worked with SEAI before, for example, and we also have, some proposals ongoing with Irish partners as well. So, yeah.
Yeah, just
Great,
ongoing,
thank you.
Ongoing. Yeah. Okay, everyone. Thank you very much for your time. Thank you very much to everyone involved, certainly to you, Dernis. Thank you very much for your time and giving us all that stuff from EMEC. Like I say, the video is recorded. So we will be able to share this. If you've got further questions, please do reach out and let us know, and we will, endeavour to get them to the right person, and you can start a conversation. That's the main thing. So, but thank you everyone for your time.
Thank you all, and thank you very much for the invitation as well.
Yeah, no, very much appreciate it.